Hey there, this is Mr. Alexander, and today I'd like to talk to you about calculator strategies as they relate to linear regression. So everything I do today is going to be on the TI-84 Plus, and what we have here are a scatterplot with a line going through it and a table with some data. And in this table we can see, this is from the bull rider data, we've got 5 riders, number of buck outs, which is the number of times a rider and bull left the chute, and the number of rides, which is the number of times the rider remained on the bull for the full 8 seconds, which is what they're trying to do at the rodeo. The first thing I'm going to do is go to Stat Edit, and I'm going to type in the data for the buck outs and the riders: 23, 10, 62, 2, and 4, and then 5, 1, 11, 1, and 1. What I need to do is first find these means and standard deviations of these individual variables. I need to know the mean of x, the standard deviation of x, the mean of y, standard deviation of y. The easiest way to get that information is by going to Stat Calc 2, two variable statistics. X is my list 1, y is my list 2. That all looks right. Nothing in the frequency list because I don't have frequency data. I have raw data. I'm going to calculate this. The x bar there, that is your mean of x, and it's 20.2, as you can see. Standard deviation of x is s sub x, which is 24.76. If I scroll down, I can find my mean of y, which is y bar, which is 3.8, and my standard deviation of y is right here at 4.38. So I definitely need to know these standard deviations because they are important when we're calculating the linear model for this data. But these means, they don't show up until a little bit later when we're using after we've calculated the slope. We need these to calculate the Y-intercept. But these means are also important because right here you see this linear regression equation that's already graphed. We're going to find the equation. I went ahead and graphed it early. This line always goes through one specific point, at least one, but one in particular. It always goes through the mean of x and the mean of y. Let me show you what I mean. If the mean of x is 20.2, if I just draw a straight up and down line at x equals 20.2, and the mean of y is 3.8, if I just draw a line, a horizontal line at 3.8, hopefully you can see that these things intersect right on top of that line. That line should go through the mean of x comma the mean of y every time. I'll show you that when we get the actual equation, but right now we don't have the equation yet of that line. We can confirm all that in a little bit here. What we're supposed to do to figure out the equation of this line, this least squares regression line, also known as the linear regression model, is solve for the model parameters, meaning r, r squared, a, and b. B being the slope of the equation, a being the y-intercept. Let's start with r. The easiest way to get r, you might remember from my Unit 2 video, is to do Stat Calc 4. But you'll notice that when I do this, all I see are the a and the b, which we're going to use later to confirm the a and the b that I get for my equation. I don't see the r and the r squared like we did in the Unit 2 video. To get that r and r squared to show up, we have to do second 0, go to the catalog, and just turn on the diagnostic. There's a slightly faster way to do this on the TI-84, but since on the TI-83 you have to scroll down to diagnostic on, hit enter twice, I'm going to show you this slightly longer way. It works every time. Once you've turned on the diagnostic, by going to second 0, scrolling down to diagnostic on, hitting enter twice, you're going to do Stat Calc 4 again, and you'll see now that we have that r of 0.989 when I round it. also have this r squared. I'm going to go ahead and copy that down too. R squared, which is just literally this number squared, is 0.978. Let's talk about what those mean. Just a quick review from Unit 2. That is a correlation coefficient. And that correlation means that there is a strong positive correlation between buckouts and number of rides. That's what that means. The r squared then, if that's r, the interpretation of r squared is that 97.8% of the variation in rides completed can be explained by the number of buckouts. So that's just a little bit of Unit 2 review there. Now it's going to be important here as well. The reason that it's important now is that what we're going to start doing in Units 4 and 5 is we're going to be deciding which model is the best. And the r squared is always the answer to that question. Whichever r squared is higher, whichever one's closer to 1, that's the model you want to pick every single time. You always want to pick the model that explains the most variation. So whichever r squared is highest, that's the one you want to pick. That's the reason I interpreted that here. But that doesn't really help me get the model parameters, which are the slope and y-intercept from the model. So from your formula chart, there are 3 things for Unit 4. We've got y hat, which is the predicted value of y, equals bx plus a, where b equals r, the correlation coefficient, times the standard deviation of y over the standard deviation of x. And a, the y-intercept, is y bar, the mean of y, minus the b that we're going to calculate, times x bar, the mean of x. So we should logically start at b, because I don't have this b yet, so we need to calculate the b. So I'm going to come over here. B is r, the correlation of 0.989 times standard deviation of y, which is 4.38, divided by standard deviation of x, which is 24.76. And when you type that in your calculator, you end up with 0.175. That is the number that's going in front of this x, which means that the slope of this equation is 0.175. For every time that x increases, y is going up by 0.175. Now I can calculate a, the y-intercept. And a is y bar, which is 3.8, minus b, which is 0.175, times x bar, the mean of x. And when you calculate all of that out, you end up with 0.265. So this equation, the y-intercept for it, is at 0.265. So here we are. We've got this equation, and we should write it out now. We've got the parameters. So the predicted value of y equals 0.175x plus 0.265. Slope, y-intercept. Is it right? How do I know? I can use the calculator to double check it. So you remember when we calculated the correlation and the r squared, the coefficient of determination, we did StatCalc4. Well, there were 2 things on there that we didn't talk about, an a and a b. And they're actually the opposite of our a and our b. But if you instead think about them in terms, not in terms of letters, but in terms of definitions, this 0.175 here is the slope of the equation, which is 0.175 there. And you can see that our y-intercept is the same as their y-intercept, 0.265. So just be careful. Our formula chart has it bx plus a, not ax plus b. Actually, if you do stat calc, is it 8? I think they switch it. And then it's consistent with what we have. But it's irrelevant. The numbers are the same. You get the same answer. And so we can feel pretty good about what we've got there. The last thing we should do on the calculator here is make sure that this equation makes sense with the data. So when I type in the data into stat edit here, there's a way I can get the calculator to show me that data. If you go to second y equals, turn on the stat plot. Second y equals, enter, plot, turn it on. Go to zoom, and I like zoom stat the best. I can see this data. And I can see this linear thing going on here. It looks like a linear pattern. If I'm going to feel good, if I'm trying to double check my work, I want to make sure that the model is the correct model, I should graph a line that goes right through here. We'll just type in the model that I got. 0.175x plus 0.265. When I graph this, hopefully I see a straight line going through all the data points. That looks pretty good to me. Now, don't expect it to touch all the data points. That should never happen. This is just kind of like a moving average. We'd expect like an equal number of points above and below the line. All the points should be relatively close. This looks good. This is a good way to double check your work. So that's how I use the calculator to help me find the model, help me double check the model. I showed you two different ways to double check the model. Just stat calc forward will tell you the equation, graph it, and that will make you feel better that, yeah, it went through the points, I'm feeling good. Do all these things. These are excellent strategies to do linear regression on the calculator. Alright, thank you for watching. I hope it was useful. We'll see you in Unit 5.